Hey, Aaron.
Good afternoon, my esteemed colleague.
Happy Thursday.
Hey, happy Thursday.
Little do they know this is pre-recorded on a Wednesday.
Ooh.
We're getting fancy now.
Hopefully this ages well.
Yeah. Hopefully nothing changes in this. Nothing
in the next
groundbreaking
24 hours.
in the next 24 hours. Nothing changes in the world of what we're talking about today, which is Bastion hosts. And I think this is one of these topics you and I assume certain things sometimes. Okay, more you assume certain things sometimes. You assume, well, everybody knows about this particular topic, and then sometimes we talk a little bit, or we see evidence. We see the environments from some of the scans we do of networks here and there, and realize maybe people
they don't understand what we're talking about.
Yeah, maybe they don't know about Bastion hosts or kind of whatever the topic du jour is. So,
yep.
So topic du jour today is Bastion hosts.
But you got it.
All right, here, intro time. Would you say that longer intro is a little self-important, maybe?
I think maybe we're a little self-important.
Okay, it's perfect then. All right, yeah. Bastion hosts. This is your topic, brother. This is you had the passion to do this one. So tell us about it. What are you going to talk about today?
Well, as always, my topics start off with confusion. So hopefully I'm not the only one, but we've gotten involved, over the past years with a lot of folks that are interested in network segmentation. And there's, I have a tendency to over-rotate on the detail and complexity when it comes to network segmentation.
Right.
And as I've learned more about enterprise networking and the state of the union thereof,
right.
I think I've had to pull back from nano segmentation and how we do host-to-host encryption with IPv6, and kind of it felt a little unnatural. We pulled back into like, how do we use VXLANs inside of environments? That's a 15-year-old technology that's still, I would say, underutilized.
It's ever new.
Ever new. His mercies are new every day, Brian. And then I was helping a couple of clients, and I realized really what they were when they wanted to know about micro-segmentation, which seems to be a new hip term.
Yeah.
Especially as, we talk about software-defined perimeters and zero trust.
Zero trust.
Yep.
Micro-segmentation.
Yeah. And really what folks are asking for is a segmentation plan. And so I want to talk through that a little bit.
If I could summarize everything you just said in my own language. You come from this service provider background with a set of assumptions. Well, you start with very secure, and you don't put every customer on one segment. You build the segments you need to do particular things. And as you've come into the enterprise world, it seems like we have started with different assumptions.
Yeah, with different assumptions. Yeah.
Here's my core switch, and plug everything into it. and I start with one VLAN. Do I need another one?
Well, and even like maybe we got over the hump of one broadcast domain, and we built different VLANs, and we're like, ooh, there's a server VLAN, and there's a camera VLAN. And, from a network hygiene perspective, that's really, really good because it helps us limit our broadcast traffic. But then what we did is we got really cheap layer 3 switches. I shouldn't say it really cheap. I'm sure people have spent a lot of money on these, but relatively speaking to older, layer 3 switches. And now we route all that junk together.
Right.
And from a security perspective, it kind of doesn't matter that you have VLANs if you're routing it all together.
Yeah. Well, and again, I would say it in another way, kinder to my brethren that I came up through, but it's you start with, build a network. You start with just set things up so things can talk to each other. And then the premise of most enterprise networks is, do I need to add a security layer somewhere? And I add those piece by piece, as opposed to kind of this change that people are struggling with, is that we would have done better off in the reverse, coming at it from the reverse direction of what security boundaries do I need? And then how do I architect a network around that? And so we're in this weird world where we built generally open networks. And so there's this question of how do we get to a more secure design that looks a little bit more like, starts approaching and moving towards the service provider network.
Well, and service provider, fine, but just let's talk about why the segmentation and network segregation is important, because we chat a little bit about privilege escalation and lateral movement inside of an environment, and when we treat the network with the old hard candy shell around it, once you get into the squishy center and I have access to an asset without segmentation and the appropriate segregation of the networks, I can make massive lateral movement. And if you think about it like a ship with no bulkheads inside of it, if the hull gets breached on the ship, the whole thing fills with water and sinks. And we put bulkheads in so we can seal off compartments inside the environment. And that's kind of the same thing with network segmentation and segregation, is it allows us those bulkheads to, start to add security layers to the environment. And so the question comes up, how many segments should I have? And that's where we get twisted around, where you can have as many segments as you want, but if they're not segregated, if they're all routed together, it kind of doesn't matter how many segments you have, because at the end of the day, it's one big attack surface.
Right.
So we're going to talk through that a little bit today, and I'm going to share with you kind of what I see and then what I think is a good way of doing it. And hopefully this is an easy way to think about it. And then you should make fun of me the whole time while we do it.
No, that's all good. I will.
So let's see.
Yes, you're bringing that up. I was laughing earlier because I remember an English teacher I had. I feel like our answer when people ask us how many segments should I have, it's like the English teacher I had in high school when we'd say, how long should my paper be? Our English teacher would always say, long enough to cover the topic, basically, some dissatisfying answer like that. Like I wanted, 3 pages, 4 pages.
Well, and then sometimes we can become too verbose and we're using words we don't need to use, and that we can over rotate on network segmentation. And I think that's where people are getting stuck, is they're going too far, too fast with network segmentation. And so today I want to talk about what matters the most with network segmentation, and then we can get into what, this is going to be really good. You can make it better than this, but if you don't have this in place, you don't need the other more sophisticated versions of this. This is the foundation that I believe everybody should have as far as network segmentation goes. What we're going to go through, not this picture. Okay.
Yeah.
So this is, and again, if I've oversimplified network.
You can go ahead and click hide on that little.
Oh, there we go. Okay. Would you look at that?
Awesome.
All right. So this is what we see most of the time. when we've got some pretty sophisticated tooling where we can map a network out with super cool things like layer 2 trace route and a lot of fancy stuff. But anyways, we do it really quickly. And this is what we get, where we've got, some of our more trusted components, servers, storage, maybe backup arrays, lots of facilities like UPSs, HVAC systems, door locks, cameras, all
badge,
that.
Everything.
Yeah, right. They're kind of go on some of their own VLANs. Maybe it's one VLAN, maybe it's 10, right? Depends on your sophistication. Then we have all these more like untrusted VLANs, user devices. Maybe it's OT stuff out on the shop floor. Surprisingly enough, most of the time the admins are out on untrusted user networks as well.
They're just users. Very often they're just using their Brian Quick at FuFuBunnyEnterprises.com. I'm using my Brian Quick account as both my user account and my admin account.
And I'm going to say 9 out of every 10 that I see are this architecture. And
correct.
So to me,
I'd point out too that, like, looking at this diagram, the first time I did with my enterprise mindset, well, I am separating, Aaron. I've got my untrusted VLANs and my trusted VLANs, at least, right? I put them on these different VLANs. Isn't that
right? But then the router just goes boom and connects them together for you. Right. So if I'm a threat actor, and we've got a lot of people that are like, hey, but I spent all this money on name brand firewall X, so I should be good to go. But if I ever compromise this firewall and get on the inside, like maybe this laptop or whatever it is comes in with a piece of malware.
Sally in marketing opens that weird Word document that has a macro that downloads software, and now somebody's got remote access to Sally.
And with the things that we're able to do with encryption, rootkits, and malware, almost without exception, once that malicious payload gets inside the network, that firewall is useless.
Correct.
Now, we can have philosophical debates about that, but once it's inside, firewall's pretty much.
Yeah, I mean, all apologies to our friends that sell like intrusion detection systems. Sure. They don't detect this.
Yeah, it kind of doesn't.
Yeah, it doesn't. The model doesn't work.
So now I can sit out here on this laptop and start enumerating all the servers and storage arrays and be like, oh, look, cool. There's a UPS that has, Telnet with a default password on it. Let me just power that crap off. Or we've even seen it where they're not authenticated, and you can literally just go right to the web tool on the UPS and go boop. Yeah. Right. Anyway.
Or go to a web page on a network attached storage device and access all the file systems. Yes. Yeah, we see that every once in a while.
So the question comes, why should an asset, that's a conference room phone or a user's PC have a need to talk to a UPS? That's kind of an extreme example, but I think makes the point. And so it starts to beg the question of, how do we segregate, even if we have segments that are all routed together, how do we segregate the environment so that, we can do some access controls and say, this type of thing never needs to talk to that type of thing.
Right.
I think where people get hung up is in the sometimes. Well, how do I decide if this user really needs to talk to that application? Yeah. And that's where I think they've gone too far. If you don't have the nevers solved, you don't need to worry about the sometimes. Okay. Yeah. And there's a lot of never situations that we should be working on.
And again, I'm going to bring my, enterprise IT perspective to this and say, when people look at this design and contemplate what you just described, I think, the first kind of the steps people go through in their mind, one of the first steps is like, I spend a bajillion amount of dollars on that firewall that you mentioned. And the only way I could picture maybe doing this is where you have a router that just moves traffic back and forth. It sounds like maybe I have to put another firewall. Like, that's where people's minds go.
It is. And that's where we went. We went to zone-based firewalls, and we would replace this router like this.
Yeah.
we would move that firewall. And maybe you had two, one that terminated the internet
right.
and one in the middle. A lot of people didn't. They just hairpinned their traffic through that firewall and built zones, and we'd have trusted and untrusted and,
right.
you know, whatever the new word for DMZ is that I don't know yet. That thing.
Right.
And we would do that. But that got super complicated, because if you ever know about rule rot inside of a firewall, if you're not like super careful with that, all of a sudden things are just routed and exposed to the internet, and that got super wonky.
Well, there's another problem. There's another problem in this design that people ran into. If they were spending $1 bajillion on their internet firewall,
now times 2.
Yeah, if not times 10, because generally the east, what you'd call the east-west traffic, the traffic inside of the network of users to servers,
from orange to green kind of here,
that is typically significantly more traffic than even the internet traffic. Those dynamics are changing a little bit as so many of our applications move to the internet and internet.
But you're still rate limited by your upstream to the internet. Internally, you're kind of not rate limited because you have a lot of bandwidth. So
and firewall ports are just always slower than, you know, routed or switched in particular ports. Just move the traffic as opposed to evaluate the traffic as it's moving. Yeah.
And for a lot of these things, we don't need next gen firewall capabilities or any type of advanced services. We really just need basic firewall capabilities for the never and always rules. Now, when we get into sometimes and we have to do traffic inspection, we need advanced services. But a lot of this, we're just going to say, hey, if you're on the user network, you can never talk to my UPS. You can never talk to the administrative plane of my storage. Right. You can never RDP into a server.
Right.
Okay. And that we just need basic firewall rules to do that. And so one of these $1 billion firewalls is not practical.
Right.
So
I will say another thing that is tough about this design is, again, enterprise IT comes from a world where we're used to plugging things in and they just work.
They just work. Yeah.
And in this model,
document it,
it's that you have to be it's not easy in the enterprise IT world because it's secure to be very specific about what should be allowed. But that means you've got to be very specific about if I'm a user and I need to talk to, you know, a Windows file server on this server in your diagram, I got to go figure out and open up every one of those ports, you know.
And sometimes in organizations, the team that manages the firewall rules is different from the routing and switching team. You've never had this happen before, and they don't like each other.
No, come on.
They want to kill each other. It's like, have you ever seen Anchorman and the news anchors are like killing each other in the parking lot? That might happen. I can picture this situation.
Yeah, network versus server. Yeah, no, never.
Or firewall guy, you know.
Never, except always.
Except always, yeah. And so that gets weird and kind of didn't become practical, but people tried it. So anyways, so that was an attempt at it. I've largely discounted this approach. I'm not saying there's not certain applications for it, but it's probably not a good idea.
Yeah.
So then I'm gonna go to something that's better than the first one that we showed, but not awesome. So if you need a place to start, I think this is where we go. Okay. And this is.
And by the way, I would say, I mean, I've done this consistently in my career in IT operations, but as we work with customers, we're seeing even this design or better, and fewer than 10%.
Yeah, this doesn't happen very often.
Yeah.
And so what we would do in this design, and I'm sure we can have a religious debate about the difference between a jump box and a Bastion server. But technically, this is the architecture for a
today. We're not going to worry about such.
We're not going to worry about that. You can send us hate mail later about whether you think we're right or wrong about this. So essentially, what we do is we leave the network segments as they are, and you can enforce network segments with the underlay network, is what we call it. Like create a VLAN or VXLAN.
The normal network, yeah.
The normal. You think of a router and switch, and you create network segments by enforcing port membership in VLANs or VXLANs. You can also create network segments through a firewall approach. And people are going to be like, yeah, but that's not a network segment. Go read the industry documentation. It's now considered a micro-segment if you are using firewall rules to build network segments. And so we're not creating new VLANs. We're not breaking down the routing of all those VLANs. We're using host firewalls. And as we implement more modern NASs and servers have had firewalls for a long time, but even appliances, like you get a new, I won't even mention names. They come with a host firewall that you can enable and configure rules. And so basically what you can do then is start to segregate the traffic and say, maybe in this storage array, we enable the host firewall and we say the only assets that can talk to the storage array on the NFS port or the SMB2 port is an allow list
or that web the web administration interface.
Yep.
Or
maybe
whatever.
The only thing that can talk to the web administration is this jump box, and we create a denial policy, and then we have allow lists of servers that can talk to us on certain ports, and then this jump box, and the jump box is for administration. And you can do the same thing on these servers. Say the only thing that can talk to this server on RDP for administration is this jump box. We don't let the admins in their laptop talk directly to the server on RDP because there's too much variability in what network segment they're on, or are they remote over VPN, or all these different things. And so the rules management gets really hard in that case. But if you create this trusted relationship with a jump box and deny everything else, you effectively have a version of micro-segmentation.
Correct.
Now,
that's a key point. And when you and I started talking about this, it was like it was a little bit difficult for me, but I think I totally get it now, which is host firewalls used consistently is absolutely a valid approach to micro-segmentation.
It actually might be one of the better approaches to micro-segmentation. That's an argument for a different day.
Well, and it's certainly, if I look at this model, and again, I think like a traditional, network administrator or, a manager of IT operations, I'm not buying a $1 billion firewall. Mm-hmm. These firewalls that exist on the storage and server device are hopefully built in, to the capabilities of that mm-hmm. thing. A jump box. There are, I know there are solutions I can buy, which are, super special jump boxes. But also I could build up Windows or
Think
Linux
of it like VDI for system administration.
Correct. And that comes with the benefit too of this isn't for system administrators. This isn't even necessarily, it's not like this diminishes their capabilities. In fact, it might make their lives easier to have a consistent place they get onto where their tools are installed. And
that's another important point, because then you have like one or two places to go in jump boxes to make sure that all the administrators are using the latest version of the vSphere client, and on and on and on and on.
Right.
So there's just so many benefits.
Well, and there may be, beyond the security benefits, there might be compliance benefits of this approach as well. Like if you're in an industry where, hey, I need to track the activities of mm-hmm. Database administrators or something along those lines, instead of like trying to put a network solution in place or some sort of tracking software on individual admin device, I can consistently put a tool, or even, put a tool on every database. I could just capture what are all the activity. It becomes a logging exercise of what are all the things that are done
that happened on this box, right?
Yeah,
and instead of doing, debug level logging on 100 boxes, you're doing it on one. And so if you don't have the resources to go implement MFA on all your servers and PAM and, very intensive logging, this is a way that you can take some middle ground that you can put it in. And a jump box is actually something, and this is, I know you want to have this argument with me, I think somebody can do in hours. and you can go do this through attrition. I hate forklift upgrades. You can put in a jump box and go like pick your most critical server today, go build the host firewall on it, and you have a jump box for that server. And then as you touch the rest of your servers, appliances, etc., you can start to incorporate.
I will agree with you. There are sophisticated, expensive, long-term forklift upgrade kinds of ways that you could do this, but you could also go grab a relative, an unused server or even a spare desktop, for goodness sakes, and provision it in a day or two and get, as you said, and get started. Be a little,
and to be clear,
agile.
This should not be a virtual machine running in your VM environment. You can make it work, but then when that box loses connectivity to like you get in this split brain scenario.
You should give a little thought too. You should have a couple of these. You should have some redundancy if you're going to set this up so that when bad things happen, I have to still be able to get into this to restore services. Then you should give some thought to, hey, how do I make sure that this is
I have a much more detailed reference architecture of this. This is obviously the
Tinker Toys version.
So if you need a detailed reference architecture, I can help you with that. So I think this is a good way to do it, where you're kind of bolting on some form of host-based micro-segmentation with a jump box, and that is going to reduce your attack surface so many fold over whatever fancy magic security tool people want to sell you today.
Right.
This is just really good practice.
Well, it creates a world, again, go back to my hacker is on Sally's computer and marketing over on the untrusted side, the users and devices world. They don't have sort of all of the servers and storage to go attack. They first of all have to know that the jump box exists. Maybe don't call it jump box 01 on your network.
Good point.
But also, so it does centralize things, but it just, instead of trying to secure 1,000, server storage, other devices, you put your time and attention into
like having one door that's heavily guarded versus 1,000 doors that are just kind of, we don't have the resources
kind of there. And some of them are screen doors.
Right. Yes. Yeah. And if we just follow, I'm going to get academic for just a second on this, and then we'll go on to the next one. If we follow out the journey towards nano segmentation and into, a zero trust model, the entities, the person and non-person entities and the environment, the server, the storage arrays, in a zero trust model, we do rely heavily on the host for its own security and the overlay networking and what it participates in and its hygiene. And we rely less on the underlay network for policy enforcement.
Right.
And so from an overall network strategy,
you and I are believers, keep the network dumb. I mean, there are some large network equipment vendors
that don't like that.
Don't like that. They want the network to be really, really smart. And because that, well, we won't get into that.
But anyways, if we look at how the cloud works, right? If we get into the bowels of how a cloud data center works, or, these more future looking architectures, we don't really rely on the underlying network to have the intelligence. We rely on the hosts to do so.
Right. Yeah.
And so
hosts and services. Yeah.
From an educational perspective, get used to this concept. Directionally in your architecture, this is the route you want to go. And so I think it's consistent with that. And this is just kind of like the first step into it, if you will.
Yeah.
Okay.
Right.
So this is good. Now I'm going to go to...
I'm real quick, by the way, I kind of mentioned this, that this could be a Windows box or Unix box, Linux box with RDP or SSH or that sort of thing. Certainly there are all sorts of the privileged access management space. And so we don't usually, throw out names of vendors, but that's the, CyberArk, Beyond Trust, Psychotic, Manage Engine,
There's lots of them.
There's all sorts of them, but many of those, that's the world. Like if you feel like you must have a commercially supported solution, those are some of the folks you're talking to.
But a lot of the folks we talk to, they don't have budget for that, or they don't have budget for it right now. If you want to do something right now,
get started. Yeah.
Grab 2 old PCs, cluster them, build a jump box out of it, and go build a bunch of host firewalls. And you're going to reduce your attack surface by tons and tons.
Yes.
Okay. All right. So this is good. And I love good, better, best. This is good. And I'm going to cover better. Best goes beyond a Bastion host and things like that. Yeah. So I'm just going to call this next one better. I'm not going to call it best.
Right. Okay? This is going from the what can I do to a day to what could I do in a week or two with a little bit more money and a little bit more focused effort.
And maybe not even more money, just a little more effort, right? If I've got the time to put some effort into it, this is the next one that we go to. I don't know how much in parts and pieces it's going to cost more. So this is where we get into a Bastion. And whereas the jump box lived on the same flat networks, the Bastion actually connects 2 different networks together. Okay. So you can think of it in terms of, we're not actually routing traffic from a layer 3 perspective, but from a layer 7 perspective of, hey, I'm going to log into this box and that box gets me connectivity to this other one. That's what makes it a Bastion versus a jump box. Does that make sense?
Yeah. Right.
Okay. So it's connecting.
And so those could be different network. Help me out here. Those could be different network cables, or they could be some sort of, we talked about underlay networks before. It could also be some sort of overlay. You can run
VLAN trunking into the host. You can, you could do a lag group into a switch and configure it as a VLAN trunk and, do all those kind of things. It depends on what your capabilities are. And again, I have a more detailed reference architecture if somebody wants to see that. But the Bastion really now becomes the only door into that network. Now, we're still running the host firewalls in these situations because that's good, and you should do that on everything you can.
Right.
And then what we're saying is that they'll only, on this control VLAN, now you can see this control VLAN doesn't even go to the router. It doesn't even pass through the core router in a lot of cases. It's just this administrative VLAN. So we take our administrators and their workstations and we put them on their own VLAN. And that gets some special logging and access control to it. So that allows us when we want to talk about zero trust and that we're doing mandatory access control, in order for me to say, hey, I've got these 30 administrators, it's easier to do mandatory access control than to apply it to my entire user base of, thousands or tens of thousands of devices. So if you're going to get used to doing, zero trust network membership, do it with the administrators first. And if your admins oppose that, you should hit them with a pool noodle.
Sometimes to change the people, you have to change the people.
Yeah. But that's a great place to start with zero trust. So do a zero trust administrative network that's its own VLAN, VXLAN, however you think about network segments. Do mandatory instead of discretionary access control. So if you have a NAC, if you want to create MAC allow lists, whatever, however you think about that. And only that admin VLAN or VXLAN can talk to the Bastion server. Then they log into the Bastion server and from there have their administrative toolkit that they use to, check on the UPS and hit the, HVAC system and manage the storage array and all those kind of things. And that's a virtually or physically separate control network that we maintain. And when you think about service providers, big cloud data centers, these are physically separate networks. They're air gapped between the two. And so we're not, it's, in some cases, we've over rotated on the convergence of networking. And when I think about that in the storage world, when we used to run SANs, which I see people moving away from, fiber channel inherently was an air gapped network.
Right.
And now that we've converged that and run fiber channel over Ethernet or other things, we've lost the hygiene.
Fun. Yeah.
Yeah, we've lost the hygiene and security practices that were inherent to these segregated networks. And so we got to bring some of that back.
Right.
And we've lost that when we just rotate to all Ethernet in a lot of cases. Then you'll see we also have this core VLAN, which is a special VLAN just for servers to talk to storage. And there's a special network when we run hypervisors that they need to mount their data stores and do things that are really to be done in private. There are only conversations that should be happening between the server and storage array, and nobody out here
selling and marketing doesn't need to be part of that conversation.
There's no one ever that needs to be part of that conversation. No user device, no thing on your manufacturing floor, no video camera ever needs to see that thing happen. That's a very intimate conversation. But what we see is that's just
hanging out there in the wind.
Hanging out there.
Yeah.
For everybody to see. So that's a thing that even typically the Bastion server doesn't have access to. It's just a special thing for the servers and storage. And then we still have the same untrusted VLANs, one or more of those, and probably, this DMZ type situation where we're creating special firewall rules. That's a deny all policy.
Right.
And this is where we're getting into.
And what is the purpose of that server? If it's my intranet web server, then port 443.
That's the only thing that's open.
The only thing that's going to be open. Sally doesn't need to be able to remote desktop that server though.
And once we get this architecture put in place, it's kind of a hybrid between air gapping with physical or virtual underlay networks on the very important things like administration and control networks, and then using host firewalls on the user networks, just in treating a user network like it's the internet.
Yeah.
Right. That we kind of don't trust anything that's on it, and we're only going to expose ports that are absolutely necessary. So how would you expose those services to the internet if it were? And the host firewall allows you to do that on an asset by asset basis versus some big bang VXLAN or re-architecture of the network. And I think that's the only way we get to zero trust is a little bit over time.
Yeah.
I don't see people doing these big bang network upgrades.
Yeah. Hey, we're running this great topic.
Okay, I'm gonna give one more real quick piece, and then I'll leave it. And that
I have just a couple of things to add at the end too.
That gives us a point where if you're going to do increased logging, if you're going to apply extra scrutiny from a SOC or threat hunting through an XDR, and you're going to apply really heavy multi-factor authentication, especially if you're going to use like physical keys to do so, do it at the Bastion. It's one point to do it, and then work your way into adding it onto your storage server, hypervisors, etc. So I think it's a great way for people to start the need to get stuff done.
Yeah. The piece that I would add, sometimes people up in the server storage, the host-based firewalls, IT teams are sometimes hesitant in doing that because I got to touch individual device configurations basically. And so there are technology solutions out there for, managing,
host firewalls.
Firewalls. That's certainly the case. And they're both, sort of open source approaches to that, as well as, commercial solutions to manage a fleet of host firewalls on different operating systems. Their piece, I would say, this Bastion piece, this is an area where when you start looking at putting these pieces together, this is, again, where people sometimes find themselves like, oh, this is the point where I need maybe a commercial privilege access management solution. But you can also, all these things, the SIM, telemetry on those, extra telemetry on those Bastion hosts, and even the multi-factor access management. I've seen people do that, with more, more of a Google authenticator as my multi-factor access management, and maybe, Wazoo, which we've talked about in other discussions here, becomes my extra monitoring of these boxes.
And if you only have time and money to do it in a few places, do it in this place.
Right. Yeah, no, absolutely. Cool. All right.
Awesome
topic. Hopefully this is worthwhile for everybody, and good talking to you. Well, I can't wait to see what's up next week. We'll figure it out.
All right. Talk to you later.
Later.